This video was created by a team of 5 engineering students to complete a senior capstone project at Brigham Young University, Idaho, in Rexburg, Idaho. In this video, I want to discuss the elements and benefits of a solar-powered energy system. Solar energy is the most abundant resource on the planet. Imagine being able to capture that energy so that you can power lights, electrical devices, and even cook meals each day. I will explain how to assemble and operate a simple off-grid solar-powered system safely, how to determine what your solar needs will be, and show a quick demonstration of a basic system in action cooking food. Electricity is all around us, from powering the phone in your pocket to keeping the lights on throughout the city, but it can be very dangerous, especially if not handled properly. There are several personal safety concerns to be aware of, such as the possibility of electric shock. When working with electrical devices, you should always read the safety labels and determine the safety limits of your device. When setting up your solar energy system, ensure that all sensitive electrical components are stored somewhere that will not be exposed to water and other elements that could damage the components and cause harm to you and others. Getting burned is another risk when using electrical devices. Electricity can be used to power lights and cooking devices, which can potentially get very hot and burn you if you touch them. It is important to keep all electrical devices out of the reach of children and in a safe place where they will not be knocked over. Exposed wires should always be covered either by electrical tape or heat shrink wrap. Damaged wire and components should be replaced to prevent malfunction and cause damage to the system and surroundings. Ensuring that your system is set up correctly will help keep you, others, and the system safe. I will now explain a quick overview of an off-grid solar energy system. It consists of 4 main components: solar panels, a battery, an inverter, and a solar charge controller. The solar panels, shown in the yellow box, capture the energy from the sun and transform it into electrical energy. The solar charge controller, shown in the red box, prevents the battery from being damaged by the solar panels by regulating the voltage and current that goes from the panels to the battery. The inverter, shown in the purple box, transforms the direct current from the battery, shown in the blue box, to alternating current, which can then be used to power household electrical devices, just like plugging into a regular wall outlet. One of the most important parts of setting up your system will be to determine the proper wire gauge size needed to connect the components of your system. To do this, you will need to know the amp rating of your system. You will need to find the solar panel specifications and determine 3 things: how many watts, volts, and amps the panels are rated for. Divide the watts by the volts to determine the amp rating of your system. Once you have done this, you can determine the proper size wire for your system. This chart shows different wire sizes and their respective amp ratings. It should be noted that the wires used to connect the battery to the inverter will be a different size than the wires used to connect the rest of the system. Now that we have a basic understanding of a solar-powered energy system, we will demonstrate setting up the system and using it to cook food. Depending on your system needs, your solar panels can be connected in series or parallel. To connect the panels in series, connect the female end of one panel to the male end of the other panel. In series, the voltage of each panel adds, while the current stays the same. To connect the panels in parallel, connect the female end of each panel to the splitter. Connect the male end of each panel to the other splitter. In parallel, the current of each panel adds, but the voltage stays the same. Fuses are placed between different components of the system. They regulate the maximum amperage that can flow between devices, which prevents damage to the system. Fuses should be rated for a smaller amperage than the wire. Here, a 30 amp fuse is being installed on the positive, red wire, between the solar panels and the charge controller, meaning that no more than 30 amps of current can flow between the panels and the charge controller. Because the fuse is placed in line, it is necessary to cut, strip, and insert both ends of the wire into the fuse. Then securely tighten the wire ends into the terminals of the fuse. To connect the charge controller to the battery, attach the positive terminal of the battery to the positive terminal of the charge controller with the battery symbol. Then connect the negative terminal of the battery to the negative terminal of the charge controller with the battery symbol. To connect the inverter to the battery, use the larger cables with the larger fuse. Ensure that the inverter is in the off position. Begin by attaching the positive terminal of the battery to the positive terminal of the inverter. Then connect the negative terminal of the inverter to the negative terminal of the battery. To connect the panels to the charge controller, insert the end of the red wire from the panels into the positive terminal of the charge controller with the panel symbol. Secure the wire in place by tightening the screw in the terminal. Next, connect the end of the black wire from the panels into the charge controller with the panel symbol and tighten the terminal. Finally, we are ready to plug the devices you want to power into the inverter. In this demonstration, we are using a resistance cooktop. Remember to operate the system safely. To calculate the system loads, a specification label is usually located on the back of each electrical device. This label shows important information such as the energy input and output ratings of the device. The voltage and amperage rating of the device are highlighted in the image. Here, the yellow circle shows a voltage rating of 19.5 volts. The green circle shows an amperage rating of 4.6 amps. Multiply the voltage by the amperage to determine the wattage rating of the device. Completing some simple load calculations will allow you to know exactly what your system's energy needs will be. For example, let's say that you want to use the system to charge laptop computers. Determine how many laptop computers you will be charging. In this case, we will plan on 2. Next, determine the watt rating of each item. In this case, each laptop is rated for 90 watts. Next, determine how much time it will take to charge the laptops each day. Here we assume that the laptops would be charging for 2 hours each day. Finally, you can determine how many watt hours per day your system will need to provide. Multiply the number of items by the number of watts per item and the charging time per day. For this example, the system will need to provide 360 watt hours per day to charge the 2 laptops. Continue these calculations for each item that you will be using with your system each day, such as cooking devices, LED lights, or even your mobile phone. Add the total amount of watt hours per day for each item to determine your overall system requirements. In this case, a system that could provide a minimum of 1660.5 watt hours per day is necessary. Batteries are rated by amp hours. This represents the storage capacity of the battery. Key parameters in the battery sizing are energy consumed, voltage, depth of charge, and battery efficiency. To determine how many watt hours per day the battery is rated for, multiply the voltage rating by the amp hour rating. In this case, 12.8 volts multiplied by 206 amp hours is equal to 2636 watt hours. Here is a cooking demonstration of the system explained throughout this video. 2 100-watt solar panels are capturing energy from the sun. Next, the charge controller is monitoring and regulating the energy supplied from the panels to the battery. The battery is then connected to the inverter. A resistance cooktop is plugged into the inverter and is being used to cook rice. A link to the design guide document is provided in the description of this video. Please reference this design guide to determine the needs of your system.